Now we'll work on exercise 3 of the skeletal system, and it's the structure of a long bone. So part of what we want to consider is when we look at a bone, we can categorize it based on its shape. And there's an exercise that's encouraging you to kind of put those different bones into categories. This is a typical long bone. This is the femur, which is the longest, strongest bone in the body, and I'm really just using this one because it's disarticulated from the rest of the skeleton, so I can show you some things about it. And as the name implies, it's long and skinny. There are other types of bones, like the skull bones and the scapula, which would be flat bones, and as you can see, they're more of a sort of compressed version. But when we think about the parts of a long bone, there are some basic anatomical landmarks. So if you look on page 135 in your manual, you'll see some of these. The first term would be epiphysis, or plural epiphyses, which are the ends of the long bones. They're sort of widened, and they may be enlarged. They may be shaped to fit into a cavity. For example, this rounded region of the femur would fit nicely into the coxal bone, the hip bone, to allow movements. And so the epiphyses are the ends of the long bone. The main shaft of the bone is called the diaphysis. Again, only one of those, so singular diaphysis. And that would be the main sort of outer components. If we were able to look inside, we would see that the diaphysis is where we would find most of the yellow bone marrow, and there's a cavity called the medullary cavity there that would contain that, along with blood vessels and nerves and other lymphatic vessels and things. In the ends of the bone, the epiphyses, we'd find the red bone marrow, which is the bone marrow that's involved in hematopoiesis, which is the blood cell formation. Now that doesn't mean it's mutually exclusive, but that's where the bulk of the red bone marrow would be, in the epiphyses. Some other things to consider: this particular bone is a model of a bone, it's not a real bone, but if we were to see a sort of live bone, we'd notice a covering, a very thin covering called periosteum. I always think of perimeter, P-E-R-I. So periosteum covers the entire bone. If we were able to look inside the medullary cavity, it's lined with tissue called endosteum, which endo for within, and the endosteum is lining that medullary cavity. There's also, and again, it's not clear from these models, but there's also some cartilage that's covering the epiphyses, and it's typically hyaline cartilage. It's going to give it some cushioning and some protection when it's doing its job in joint movements, and it's sometimes called articular cartilage because it's part of the articulations or joints. So that's hyaline cartilage, and it shows it in your manual just sort of as a covering or a little cushion. Other things about the bone. I guess the other important thing is when we think about the sort of hardened structure, that's because it's compact bone. And if we can just look at this poster for a minute, I'll just remind you of the structure of compact bone. When we did the tissue types, we were able to see that compact bone has almost like tree ring structures, where it's got a central canal where the blood vessels and nerves and things would serve the bone. It's got these concentric rings called lamellae, or layers. And then the lacunae are not quite as obvious, the little chambers where the osteocytes live, but the osteocytes are secreting the matrix and incorporating calcium into the bone, and in some cases actually pulling the calcium back out. The mature bone cells are called osteocytes, but it turns out that there are different cell types called osteoblasts, which are the bone builders, and osteoclasts, the bone destroyers. And so they're working together to constantly put calcium into the bone for storage, or to break it down so we can build new bone tissue, because we constantly want to rebuild that. And then there are little canals or canaliculi that connect those different layers, those different lamellae, so that you're able to kind of imagine this tissue, even though it's solid, it is living tissue with a non-living matrix surrounding it, very hardened and protected. So just a little reminder about the compact bone tissue. So it encourages you to go online and use the accompanying exercises that go with your textbook, but I would also encourage you, in terms of starting to learn the names of the bones, to use a website called Get Body Smart. If you go to getbodysmart.com, there's a whole section on the skeletal system, and it will have the parts of the bone, but then it's also going to lead you through the bones that we're about to learn, which are part of the skeletal system. So getbodysmart.com, and it's a free site, so you don't have to pay to register or anything like that. Of course, there is the animation that goes along with the Connect that's going to kind of walk you through these different bones.